Oh, I should have wrote it down. Let's do fearless factoring. We'll start with simple ones. So we'll just increase in difficulty as we go through. Um, so we'll start with, actually, we'll start with this one. It's not the simplest. Um, a lot of time we do factoring is to change a parabola from standard to factor form. But we're going to focus on one that's more of a challenge to factor in itself and is not technically a quadratic. So we have this here. When we do fearless factoring, the idea is that we're going to find factors of the first term instead of it a, b, and c, because this is not technically a quadratic. Think of it as the first term here and the third term. So we look for factors of both of them. Factors of 6 are 6 and 1. And because we have an x squared, I'm just going to attach an x to each of these, okay? Which also means we get 2x and 3x. And then for the second part, or the third term, I should say, we do the exact same thing, 1 and 20. But again, we have y squared here, which sometimes we don't when we factor. Sometimes this is just a constant number. But because there's a variable attached, we are going to split it, okay? And we're allowed to split it because, should mention this, is because it's squared. The idea that x times x is x squared and 6 times 1 is 6. Just like y times y is y squared, 1 times 20 is 20. So it needs to be squared in order for us to be able to split it like that. That's important. Now 20's got a lot of factors. We have 2 and 10 with our y's. We have 4 and 5 with our y's. So right off the bat, we have a first column and then 1, 2, 3, and then a second column, 1, 2, 3. So there's a lot of different combinations we're going to have to try for this one. And we know their products are going to eventually need to add up to whatever the second term or the middle term was, which is 7xy. So I usually do it systematically. You might be able to look at it quickly and go, oh, I think this might be ideal. Like, I get the feeling that I think it's going to be like a 2 and 3 and something. But we're going to test our 6 and 1 to start. Okay, so think of this as its own column. We'll try this column out to start. So 6 and 1, that's going to give me 6, 20. No combination of that's going to work. And we should just test going across 1, and that's like, oh, what is that? 120 and 1 definitely doesn't work. Okay, we know that doesn't work. 6 and 2 gives me 12. 1 and 10 gives me 10. Not bad, but not ideal. 1 and 2 and 6 and 10 is 60 and 2. No combination of that's going to give me 7. And then finally 6 and 4, 1 and 5, that gives me 24 and 5. Doesn't work. And then finally 6 and 5 and 1 and 4, that gives me 34. Never works. Okay, so all we've done there is essentially got rid of the first column. We know it's not going to be 6 and 1, which is nice because there's only one more column here. So like we said, I intuitively thought it's probably going to be the 2 and the 3. Probably won't be the first one. And what's nice, as we go through these now, we can cross out these second columns, or the third term columns, maybe we could call them. 2 and 1, 3 and 20, you're looking at 60 and 2. None of that gives me a 7, which means this is not an option now because I've tried it in both of these columns. That one's gone. 2 and 2, oh, did I go across 2? Oh, no, I forgot to. 40 and 3, just for the prosperity there. That doesn't work. Good. Okay, so we can cross it off. 2 times 2 is 4. 3 times 10 is 30. Nothing. 6 and 20. Nothing. It looks like it's gone. Okay. I hope we got this here. Here we go. We're going to go 8 and 15. They don't add the 17, but the difference between 8 and 15 works. Okay? And the reason a difference can work in this situation is because the third term is negative. So because the third term is negative, technically one of these two has to be negative. When I go across it, okay, I need to make technically positive 7, which means the 15 needs to be positive. In other words, the 8 needs to be the negative term. So I multiplied by the 4. The 4 is going to be the negative term here. Does that idea kind of make sense? Okay, so now that we established that, we can set this up in 2 sets of brackets. The first terms are our red terms here, so we're just going to establish them by putting them as the first term in each bracket. And then the green terms, which are our third terms, they're the second terms in the brackets, but they are specific. Because we did 2x times negative 4y, they have to go in opposite brackets. So the negative 4y has to go into this bracket here. Okay, and just like we did 3x and 5y, they have to go in opposite brackets. That's it. That's technically it. But what we should really do is just for checking, we should carry this out. So we think we've done it. We're going to do a little expansion. We'll expand, simplify, and then as long as we get back to the original, we've done a double check to make sure. So if you remember, you're expanding. 2x times 3x will give you 6x squared. 2x times negative 4 gives you negative 8xy. 5y times 3x gives us positive 15xy. And 5y times negative 4 gives us negative 20y squared. We quickly collect our like terms in the middle. And we get 6x squared plus 7xy minus 20y squared. And if we zoom out quickly, we take a look. Yeah, that's exactly what we had started with. And when we expanded and simplified, that's exactly what we got. So that's it. We've got it once we've gone through that piece.